right. So what we're actually looking at today is we're going back to look at our focus question from yesterday. Our focus, actually the content, is we're going to look at temperature and we're going to look at latitude. We're going to re-look at that and we're going to focus on the question, what patterns in temperature can be found on Earth at different times of the year? Okay, so look what I have. I have my data table, the first sheet that I gave you yesterday, which has what on it? Average temperatures for January and July. I have my world map record page for January and July. And now I have a what? Bar graph. For January. Well, does anybody see anything that they could make a statement about with these resources that I've passed out? And can you write down Wiley's statement real quickly for us? And I'm going to hand out another resource. But Wiley, can you say that again? Just so we can make a connection with and write it down.
Depending on where you are, as the latitude, the degrees in latitude go higher, the temperature goes down.
Okay, let me help restate. As you go from the equator north in latitude, so you're increasing, aren't you? From 0 degrees to 90 degrees at the North Pole. The temperatures, is what Wiley's saying. Correct me, Wiley, if I'm saying it improperly. The temperatures they get cooler. And you're supporting that by what resources, Wiley?
Well, my the world map for
right,
and the bar graph.
Okay. Okay, so now we are really rocking and rolling. I have another, believe it or not, it's another bar graph. And I know we're getting a lot to look at, but let's make sure we keep our resources so we don't get confused. But this one, and Leila, you can tell us the title. This one is what month now?
July.
This is July. So can you take one and pass it on? And if you have extras, we're happy to have extras, and I'm going to put this one up here. And I want you to do like a think, pair, share with your journals open. I'll give you 5 to 10 minutes. I want you to look with your partner and even the people in your pod and have a conversation about, okay, now what patterns do you see with the bar graph, with your data table, and with the world map? Can you handle that?
Since July is the colder part of the year, now since July is the colder part of the year for the southern hemisphere, the temperatures are dropping in the southern hemisphere. But since July is the hot part of the year, in the northern hemisphere, the temperatures are rising.
More by the equator, it's staying the same.
Yeah, around the equator, it stayed pretty still in temperature.
Because like 6 degrees south and 6 degrees north are both in the 80s.
Yeah.
So.
And also 19 degrees. Oh, and also in Bombay, the temperatures have stayed the same.
Yeah, and then the 65 degrees north has really changed from negative 10 degrees Fahrenheit to 63 degrees Fahrenheit.
Yeah, Fairbanks.
Which is a big difference.
We have our January bar graph and a July bar graph, and you're saying what about the bar graph temperature?
That in July, the southern hemisphere is actually colder than whenever it's in January.
Okay. Do you want to provide some evidence or maybe connection with why that might be?
Because it's farther away from the equator, so whenever it's July, it might be switched from January.
Okay. Does anybody want to add a comment to that? Lala?
Well, he's right how they're in July they're all lower. Besides on 6 degrees south, and that they're both close to they're both hot because in January it's 89 degrees Fahrenheit.
And what do you know?
July it's 87.
What do you know? Why do you say that you know that they're both hot?
Because when you go closer to the equator it gets hotter.
What makes you say that?
Because the equator's in the middle of the earth, so the sun is mostly in the middle of the earth, so.
Does everybody hear what Leala just said? Yes. About temperatures around the equator, okay? All right, let me just give another, I appreciate, we're gonna come back to you guys. Was there anything that, Taylor, you wanted to make a connection with? And we'll go to your pod, Seth, Kaylee. Anybody wanna make a connection with what you noticed? Alexis, please.
If you look on the average temperature graph, if you look at St. Louis, Missouri, it's 38 degrees north on the latitude, and on January it's 29 degrees Fahrenheit. And if you look on the January bar graph, you'll see on the northern hemisphere there's a 38 degrees north and it's 29 degrees Fahrenheit, and those two are the same as the numbers, the Fahrenheit, the temperatures on the average temperatures. And in July it's 80 degrees, and it's also 80 degrees on the bar graph.
So what are you saying about these resources that you're looking at, Alexis?
These resources are all the same as the one on the average temperatures.
Do you hear what she's saying? Look up here and let's make a connection. She's saying that the data from the average temperature, the data table here, you can find this information where? Here? Can you?
Yes.
Here?
Yes.
Can you find it here?
Yes.
And can you find it here?
Yes.
So we could actually take a pencil, and I think that's the point that Dylan was making as well. He was talking about, oh, look, 38 degrees north in latitude, that's talking about what city? St. Louis. And he was talking about, oh, 39 degrees north in latitude, that's talking about what city? Denver. So we're looking at 1, 2, 3, what? Visual representations of what?
The temperatures.
The same thing. Do you understand that?